Appreciate it.
Everything is in magenta red already.
I know, exactly.
Sorry.
Actually, in honor of Oreo Inbar, I've decided to reveal my superhero self. So I will appropriately show the colors of Deutsche Telekom. So give me a minute while I retrieve something. So roses are red, violets are blue, XR is cool, and I hope I fooled you. These are not really XR glasses, but we all want them to be. So today I'm going to talk about how we actually get there. I'll put my actual reality glasses on, and I'll be able to see what you can see. All right, so to start with, today what I'm going to tell you is a little bit of a story about how we can get to Pervasive XR. And to really start the conversation, we have to talk about the devices, right? We all struggle with wanting something we don't have, such as a nice combination AR, VR, lightweight, and pretty durable device. The problem today is that most devices are designed for business cases. They tend to be bulky. We have a lot of challenges still to solve with silicon and with sensor technology. And as it stands today, we have to face a lot of compromises where we have to choose between use case specific capabilities on the devices. We tend to find that these devices still are fairly expensive. They're fairly bulky. And so today what most people have as an experience with AR is walking around holding their phone like this and trying to experience augmented reality. But if you've held your phone for more than 3 minutes, I dare any of you to do this while I'm doing my presentation, you'll find it to be quickly tiring. So obviously we want to have headwear that we can use conveniently, comfortably, and in a wide variety of environments. We don't want to force people to travel specific lanes within the reality to accommodate using these types of devices. We want to allow them to be more flexibly used. So we see some trends, and actually I did a version of this presentation about half a year ago, and I've already had to revise a number of the numbers, most of them being the prices downwards. But if we look at the history of pricing and the marketplace, we see a significant reduction occurring over the last 12 to 24 months, and we're going to see that trend continue and accelerate. We also see a very important thing, which is weight, right? Weight is one of the more brutal aspects of designing hardware, and it's one of the most challenging parts of the effort of designing these is to reduce the weight, making things smaller and smaller and lighter to accommodate the commercial consumer form factor that people want to have. Even in business use cases, they desire this. So we can see already that as we enter or begin to get ready to enter 2019, that there are devices coming on the market that are priced even lower than some of these numbers, depending on the trade-offs that you wish to take with the devices in terms of weight or whether they're tethered to a phone or otherwise. You'll find that there are products already available today that range in price from a couple €100 to 500 euros, and with compute on board as little as 1,000. So we're already kind of starting to reach some of these points. In order to achieve these form factors, there's these 5 things that are being focused on by most of the device manufacturers. Offloading the compute, which reduces the energy drain on the device and allows to use a lighter weight chipset. Improving the connectivity is an important part of that so that we can have high-speed connection to other devices or back-end network infrastructure. And then better chipsets, which we see, for example, with the Qualcomm XR1, which a lot of the companies are adopting as a baseline for building new devices. New optics technology, variations of waveguide technology, and other forms of display are being developed, and of course, new sensors. So we see, for example, compact sensors, tighter arrays, and the ability to recognize the real world and do spatial mapping more effectively. But also some of those problems are being solved by software. So Pervasive XR, what I mean by this is that today we operate in a world full of very short time duration, business-focused use cases. Usually the applications are the only, the application that is on the device is the only application on the device. The device was purchased to run that particular piece of software. The software was designed for that device. And the experiences are very short time duration, 15 to 30 minutes, with a very focused set of workflows or tasks that are being accomplished with that software. But in the future, we want to move to a more pervasive time duration extended experience. And we will see a transition into next year where we'll have experiences that last for 1 to 2 hours, such as a sports entertainment experience at a stadium or watching television shows at home, and having augmented reality glasses enhance that experience. We'll see more broad scope applications, and we'll see devices which people are using multiple applications on. As we move forward in time, we are going to have to change the ecosystem for applications from devices from being an app-focused ecosystem to a people-focused ecosystem. So instead of having a springboard of apps and selecting one through gesture, touchpad, or whatever, you're going to have a collection of services that have been personalized based on your needs and your context and your location and your time of day and your habits. And those ecosystems of services, or that ecosystem of services, is going to be forced to collaborate together to intelligently present information at the right time and the right place and in the right part of your field of view. So this is what I'm talking about, is how do we get to this particular type of consumer and business experience where I literally wake up in the morning, I put my glasses on, I turn them on, maybe they automatically turn on, and I have an augmented experience. I am a human being who is now augmented with my glasses. And this is what we're driving forward to. So in order to achieve this, there's 2 key things that Deutsche Telekom and others are working on to build capabilities to support this goal of the device manufacturers to develop smaller devices that are lighter weight, that require less battery, and provide more functionality than they can with the compute that's already on board the device. So we start with edge compute. And edge compute can be thought of as execution of computation that's not done all the way in the back of the internet connection, back in the cloud, as you will, but closer to the user physically. So we can move it really close to the user by putting it on the device. We can move it a little farther away from the user by putting it in the building that they're at, in the campus that they work at, in the factory that they develop products in. And we can put it also at the 5G base station. As we build 5G out, these stations can have compute data centers at their base. And then we can also build out from there to regional data centers. And so this allows us to build a sequence of compute on the network that is closer or farther away from the user, and the distribution of that compute is going to be intelligently performed by software that allows the orchestration of where the compute should come from to be automatic for the developer, and the services to be deployed based on the requirements of the application. So this is basically a view here of the way that the user sees things. So in terms of the types of applications that are common, we will see a lot of focus on automotive experiences, bringing compute and the low latency experiences that we need to have as a car is traveling at velocity down the road. We need to be able to predictively look at where the car is going and to decide where on the network we want to get our compute services from and transport the data from that, or the data or the compute results from that closest possible location to the user, even as they're moving at speed on a freeway. If we move further back, then we might have services that don't have the time sensitivity or it makes sense to come from the backhaul. And so we'll still be using the cloud. It's not the edge is going to replace the cloud. It's just going to move the cloud closer to the user for specific cases. So the types of things that we get as a benefit from edge compute are, of course, latency. So, we control data transfer at the speed of light. If we shorten the distance from the data center that the data is coming from to the user, then we can reduce the milliseconds of latency that occur on the internet. Now, it's not that latency kills all the time, but there are certain use cases that without low latency, you just simply can't do it, or they're not convenient to the user, they're not appropriate for the user. And certain actions that we do in XR have relatively high latency allowances, like speech recognition. We can speak some text or speak a sound and have it converted and processed in the back end, and we won't notice if there's a 10 millisecond extra lag or a 20 millisecond extra lag in the processing time. But other things such as gesture interactions or rendering based on the head position of the user, these things are going to be much more latency sensitive, and edge compute can enable that because we can do things like render content on the edge and bring the video stream of that content down to the user. So we'll see this for VR first and then AR later, but you can imagine, for example, a 50 million polygon model, a billion point cloud, AR cloud data structure, and we're dragging data out of that to render it. We obviously don't necessarily want to do that by pumping all the geometry down to the device and having it try to compute and render that, because then it doesn't achieve the goal of the form factor, and it creates a lot of battery drain trying to do all that GPU processing on the device. So as we move forward, we'll see edge CPU and then later GPU compute enable these types of immersive experiences more effectively. Another thing that we get as a benefit from edge is that we reduce the reliance on the cloud. So we don't have to push the data back through so many hops all the way to the cloud and all the way back to the user. And so that can also give a better throughput to the experience, which can matter depending on the type of application that you're building with XR. Network congestion is also a factor, right? So if we have a lot of people in one area trying to use their cell phone to upload video from a sporting event, the network starts to take a beating. I mean, I don't know if you're familiar with, you know, what it's like when 100,000 people go to a park to try to play Pokemon Go at the same time, but it can really destroy a network. Doesn't matter who it is. So this is an important aspect where edge compute on campus or in a regional location can reduce the stress on the network for congestion purposes. We can use edge to process data coming upstream from the user and reduce the amount of data transfer that has to occur back into the backhaul. So for example, if you have a webcam that's monitoring as a security situation, you have, if you were going to push that data across Amazon Web Services, you'd pay about $3,000 US a year for that web data stream. If you instead put processing at the edge and pump the data locally to an edge processor and perform analytics or analysis on that data stream, you can then simplify the data that gets pushed up, gets pushed up to the cloud to just a small fraction of that data, maybe a couple of orders of magnitude less data. So this is a very important aspect of edge, is it can actually significantly reduce the cost of operating on the network. Quality of service with edge goes up because you increase the reliability of the experience of the user. You have less hops to jump through, and so that in turn creates a more reliable, more always connected experience for the user. So in terms of use cases, as I mentioned earlier, compute offload is a really big purpose here. And so we take the specific functions for XR. You know, we take certain data that we want to push up to the cloud, and we can put it on edge instead. And we can do things like computer vision processing. We can put AI services at the edge, such as speech recognition or image analysis on video streams, semantical scene analysis on what's in the video, where are the objects, what's the relationship between the objects in the scene, how are they moving, what's the history of that. So that's really important as we do spatial computing on glasses. We can't put all of that compute on the glasses. We do rendering on the network. We also can look at adding value for things like GPS fraud, right? People spoofing GPS is a general problem. We see that with Pokemon Go. We see that with Uber. And so with those types of problems, we can actually utilize the network to validate the GPS data that's being reported by the end user device and avoid the problem of spoofing completely. So this gets better as we move to 5G, because with 5G, we are going to start the build out and utilize the existing infrastructure to start with. So we're not starting, 5G doesn't require that we have to build new equipment. We can use the existing antennas, the existing equipment to deploy 5G. And then in order to get higher bandwidth and better density support, then we start implementing millimeter wave antennas. And we place these in locations that aren't necessarily as obvious to the user, such as a street light, or a sign on a building, or other places where it doesn't create that kind of community concern, but it allows for the increased throughput of millimeter wave traffic to really bring some of the value propositions of 5G to bear. So, you know, as 5G deployment is still coming, we're not actually able today to pull a phone out of our pocket and connect to a 5G network. Now is the time to start thinking about how do we get there with our software experiences, and how do the devices support these types of experiences. So here we have, you know, a visualization that shows you all the different places in the world where we have the potential to have connection through 5G to the ecosystem around us. We can get a combination of IoT sensor data, transmitting information over 5G, and aggregating that with intelligence to tell you things like the trash can is full and the recycling truck needs to come and take the garbage out. We can get information about the wind conditions and adjust wind turbines. We can perform information tasks with the car as it's parked outside. There's all kinds of applications. We could spend days talking about use cases based on top of this kind of connectivity, but it's going to become important because it creates a cohesive ecosystem that's always available everywhere you go. So as 5G gets deployed out, and the goal of Deutsche Telekom is to have 99% coverage in Germany by 2025, we'll have, it's going to take a while, but when we get there, we're going to have the ability to always be connected to all the things that are around us, and we have to build the support for the data inside of an XR experience utilizing the 5G ecosystem to, to maximize the user experience. So one thing that I want to bring to light here is that 5G is a lot more than bandwidth. Everybody talks about how fast it'll be for you to download video content from a server to your computer, or to store a Netflix video for playback later. That's clearly a big benefit. You're going to see significant improvement in bandwidth. 20 gigabits per second is maximum possibility in a stationary space. 100 megabits per second. Consistent content down on mobile. It also gives you a value in terms of upstream bandwidth, right? The internet today is designed for consumption, not for production. So part of the value proposition of 5G is to enable users to push data up to the internet servers and to edge and to other users effectively. As I mentioned earlier, we have the benefit of latency. So there's the 1 millisecond latency promise of 5G, which is really the radio connection time. But then there is the reality of the latency that comes from the distance that the data has to travel, which is why edge matters, right? So if we bring the compute to the radio base station, then that 1 millisecond connection time, the data center is right there at the base of it. We're going to get really, really good low latency experiences. As we build out the infrastructure, you'll see more and more of that deployed. The other benefit is, or the other reality that we have to deal with is the compute time. So as we build services that operate on edge, we have to build, we have to transform, especially in the GPU space, we have to, create solutions that allow for GPU to operate in a shared way on edge. And this is going to be a factor that we'll have to deal with, but we'll net out with a significantly improved, consistent, and predictable latency on the network. So one of the things we're looking at is how do we predict latency in an XR application? If you're walking down the street or you're riding a bicycle or you're in a car, we are looking at how we can use edge compute to create a prediction network of latency. So as you move, we can inform your application that you're about to go into a lower latency environment. We can benefit from that, or you're about to go into a higher latency environment and you need to accommodate for that. Some of this is done at the chipset level with predictive rendering on the chips, and some of it's done on the network side, predictive rendering on the edge, and some of it's done on the application end on device. We get better density throughput with more people connected in one place. So when we go to a stadium or a shopping mall or Disneyland or some other place like a big show like this where there's a lot of people in one place all trying to use their phones at the same time, we can give them the kind of spectrum that they need to perform the tasks that they're trying to do with their mobile phones or with their XR glasses. The other big win for me, which is super important for XR, is location and positioning services. So how many people have tried to call a My Taxi or an Uber and had the location that was presented in the screen seriously more than 5 meters away from where they really were, right? Like a block away, maybe half a city away. So depending on the kind of problem you have with nearby buildings and other construction aspects, this could be a serious problem. So with 5G radio, we can actually really solve this problem. We can bring under 1 meter accuracy outdoors and indoors to a user. So now we can start performing or building applications that can rely on spatial computing tasks that can be localized more quickly and more consistently and more accurately. And more importantly, right now, most of the XR stuff that I see is built for either indoor or outdoor use cases. We don't have applications very commonly that allow the user to navigate in and out of a building. For example, I can get world-scale AR navigation that takes me to the front door of the building, but how about to John Thomas's office, on the second floor? How do I get there? And as you go through a big campus, this can be a big issue. I recall going to Intel, and the guy that worked there 5 years got lost going to a conference room. So this is a problem that we can solve by having more detailed location positioning services indoors. So this is really the combination of the two is the key thing here. With edge compute and 5G together, we can start to enable the device manufacturers to achieve this holy grail form factor of a lightweight device where they're focusing on the display aspects, the sensor aspects, and a lot of the compute functions can be brought off the device, reducing battery drain, allowing for that smaller form factor. The other thing is that we can start utilizing new input and output modalities, such as haptics, to create a tactile internet experience. So I can create an XR application where I can see a holographic representation of somebody who's wearing a VR haptic suit, or a haptic suit in general, and I could tap on a part of their body and say I'm a therapist and I'm trying to get them to move their arm, and I want to tap and ask them to move this part of their arm, and they're 1,000 miles away wearing a suit, and they're getting a haptic sensation on their arm instantly while they can hear me talking. And so there's no latency drag, and it makes sense to them, and it's comfortable. And then we can get feedback back across the network, so as the suit moves and we track that motion, the holographic representation can reflect that on the other end. So those are examples that are really important. Really what we're looking at as we go through this evolution of edge compute infrastructure and 5G infrastructure build out, and the devices getting smaller and smaller, is the de-evolution of the smartphone into a collection of personal area network devices. Maybe using the smartphone now, maybe eventually not using a phone at all, as these devices may have LTE integrated straight into the device, or maybe our watch will act as an LTE bridge, also as a controller, right? We've seen a couple of examples of Fitbit type of controllers here in the show, and these devices work together using techniques like mesh computing, where they share the compute capabilities of all the devices, an ecosystem of compute, and we extend that ecosystem to edge and to backhaul so that we can create more powerful computing experiences without having to put it all up here. So I have a little video to sort of end this presentation and kind of talk about, paint a picture of what's going to be possible.
5G will have such low latency that buffering or loading times will be a thing of the past. Bandwidth so large that the potential use cases are enormous. Driving a car will go to the next level with augmented reality navigation. Your great route on the slope will be so easy to share with your friends live. Cars will be driving autonomously on the streets, so you'll be able to spend your time in the car a little better. Drones will be saving lives by quickly transporting vital goods unaffected by traffic. Gaming will become a fully immersive experience due to augmented and virtual reality. You will enjoy various worlds and landscapes with your friends in the living room. These are just examples of the potential uses of 5G, but there are more of them.
So with that, I thank you for your time very much. I hope you go out there and be superheroes yourselves using XR and leveraging the development of edge compute and 5G infrastructure to create really exciting, pervasive XR experiences. Thank you.
Q&A? Here I am.
You have time for Q&A, or?
Yeah, you familiar with that sound?
Yeah.
All right. Is it actually true? I think actually the sound was created by Kraftwerk. Is that?
I believe that's true. I'm not positive, but
it's probably their biggest hit. Like everybody knows, at least in Germany knows, like the.
Exactly right.
So, all right, so let's go for some questions. Of course, when it comes like to telecommunication, people are always quite aware. So the first one comes from Marco Tillmann. Thank you for that question. Beyond the infrastructure development costs, including device to device, small cell networks, and huge data storage nodes, how will privacy issues affect 5G?
Well, I would say that privacy issues affect 4G equally. So I don't think there's any real difference. We have an obligation to consider privacy in all of the applications that we build. as we use camera to perform tasks such as spatial mapping indoors, we have to think about the fact that we're mapping potentially people that are in the room, and how do we mask that information? How do we mask out the faces of people, or obscure that they're even there at all? So it's very, very important. There's going to be privacy issues with wearing XR glasses and walking down the street and looking at individual people. Do I have the right to facially recognize them and look them up in my LinkedIn profile and see if I know information about them, and pull data from public sources and social media and present that in XR? To be determined. But I don't think it's an infrastructure issue. It's more of an application and enabling technology issue.
Okay. Going for the next one. Nico, thank you for your question. When is 5G realistically going to be rolled out in big European cities?
So, we're seeing 5G infrastructure build out happening already. We have implementation here in Germany. But I'd say that really the key issue here isn't so much the infrastructure build out, it's the availability of devices that can connect to 5G. So right now, my test device is a meter-square box on a cart. It doesn't fit in my pocket. But we will see, I would estimate we will see 5G capable devices or handsets near the end of next year.
All right, so how many, let's say I drive around with a family, everyone has an individual screen. How many Netflix streams can I have at the same time and still having autonomous driving?
Again, you have 100 megabits per second bandwidth, so depending on the compression, you could feed everybody multiple streams. That's the bandwidth value of 5G.
Just going for the
for
that side as well. Going for the next one. How does edge computing relate to the outgoing issue of net neutrality? Well,
net neutrality is more about how the transport of compute and data is prioritized to the consumer. And I would say whether the computer is in a campus, or if it's at the base of a 5G tower, or if it's in the cloud, it doesn't really matter. It's still part of the ecosystem, and it has no differentiation or no unique impact on net neutrality or be impacted by it.
Okay. Yeah. Well, the next one, I'm not sure if you're the right guy to ask that. AR glasses are Wi-Fi based, not SIM card ready, because the eSIM thing was already in Germany a big issue. So I think it's more of a question of manufacturers and.
I think there's consumer reticence to put radio near their temple to an extent, and so there's a psychology of that. We see. A sensitivity to having cell phones held up to your ear for hours on end, but yet people still do it. I predict that next year you will start seeing manufacturers commit to putting LTE on the glasses themselves, but there's also a battery drain factor to be involved. Interestingly, the chipsets that are used in a lot of the glasses today actually could have LTE radio enabled, but don't. On purpose by the device manufacturer.
That's by the phones. Those.
Yeah, exactly.
Those watches are already doing the job.
Yeah.
Okay. Next one. Edge computing. Is that just T-Mobile data center rather than AWS? What is the latency difference between those two? Does AWS have bad connections to you?
So edge computing is really more an architectural approach to how you put computing on the network and provide it to end users. It's not a company-specific approach, right? So edge computing is an industry initiative of which we are, pushing forward and leading. So it really doesn't matter whether it's Deutsche Telekom or T-Mobile or Sprint. The architecture approaches, the development is the same. Well, one thing we've done is we have a spin-out company called Mobile Edge X, which is building an open source platform for multiple telcos to operate edge compute services on. And so we already have signed up partnerships with many different telcos that can collaborate together to provide a consistent ecosystem for developers to perform tasks such as finding the nearest compute, getting the compute services installed on that service, and making it accessible to their applications. So it's bigger than us.
All right, then thank you so much for the answers. Ladies and gentlemen, please Terry R. Schussler.
Thank you.
Deutsche Telekom. Thank you.